this question. So if you observe this question, find the number of solutions of log base x3 is equal to 2x minus 3. So question number 9, log base x3 is equals to 2x minus 3. 2x minus, just a second. Log base x3 is equal to x minus 3. Now what we do is, now we will take y is equal to log base x3, or y1 is equals to, and y2 is equals to 2x minus 3. Now we'll draw the graph of y1 and y2 on the same coordinate plane, and number of points of intersections of y1, y2 are the number of solutions. So first we will try to draw the graph of log base x3. We'll draw the graph of log base x3. So for that one, first we will write we can write this y is equal to log base x3 as ln of 3 over ln of x. So ln of 3 over ln of x. So now what is the domain of this function? Domain of y1 is equals to what? Open 0 to infinity, is that no? Because ln x is there, but denominator should not be equal to 0. Ln 1 is 0. That's why that is not allowed. Minus 1, except 1. Is that open 0 to infinity, except 1. So this is the domain of the function y1. So from 0, open 0 to infinity, but except 1. This is not allowed. So this is the domain of the function. Now we will draw the graph of this function. So first differentiate dy1 by dx. If you differentiate it, then what you get? Ln 3 is constant. Differentiation of 1 by ln x. Differentiation of 1 by x is minus 1 by x square. Therefore, minus 1 by ln x whole square into chain rule. By chain rule, differentiation of ln x is 1 by x. That is equals to minus ln 3 over x into ln x square. So here our domain is x belongs to 0 to infinity to 1, therefore positive numbers only. So here x is positive because domain is 0 to infinity except 1. This is positive, ln x square positive, ln 3 is positive. Therefore this whole sign of dy1 by dx is what? Negative. So this is 0, less than 0 in its domain for every x belongs to 0 to infinity minus 1. Therefore dy1 by dx is negative. That implies y1 is decreasing function or increasing function. Therefore y1 is decreasing function. Decreases in its entire domain. The function is strictly decreases in its entire domain. Now what we do is, yes, we got it, the function is decreases in its entire domain. Now what we do is, to draw the graph of this ln 3 by, now to draw the graph of ln 3 by ln x in its domain, here we will see good morning. So we will see the nature of function at 0 and at 1. At 0 and at 1. At 0 open interval is there, therefore right hand side nature you calculate just. That is 0 plus right limit of the function. At 0 right limit if we calculate, and at infinity also. So we will calculate the limit like first one is limit extending to 0 plus. Extending to 0 plus ln 3 by ln x is equals to what? Tell me. So as you approach 0, ln 3 is anyways positive. If you, as you approach 0 from positive side to 0, then ln 3 by ln x approaches what?
0.
0 from positive or negative side?
From
negative side.
Negative
0
side.
minus or not? 0 minus. Yes or no? 0 minus. Next, limit extending to right hand limit is not, left hand limit is not required because open 0 to infinity. Now limit extending to infinity, ln 3 by ln x is what? It is 0. 0 plus or not? 0 plus. Now, limit extending to 1 plus and limit extending to 1 minus we require. Because at 1, discontinuous function. Therefore, limit extending to 1 minus is what? Ln 3 by ln x. If you approach
Negative.
1, tell me?
Negative infinity.
Yeah, minus infinity. If you approach, already we have seen all these things in limits. Next, limit extending to 1 plus what?
Positive infinity.
Positive. Yes. So with the help of this data, so our first point is y1 is a strictly decreasing function, and limit extending to 0 plus y1 is 0 minus, limit extending to infinity y1 is 0 plus, and limit extending to 1 minus is minus infinity, limit extending to 1 plus is plus infinity. So when it x equal to 1, function is discontinuous. Now with the help of this one, we can draw the graph of the function. That is, the graph will be like this. See, at x equal to 1, discontinuity is there. So here what we do, at x equal to 1, we will draw one vertical line. This is 0. This is x-axis. This one is y-axis. Now tell me, now if you observe, as you approach 0, so see this one, as you approach 0 from positive side, it go to 0 minus. So no, 0 minus. 0 from less than 0 values to 0. So, and if you approach 1 from positive side infinity, from negative side minus infinity, and if you approach infinity, 0 plus. 0 plus. Therefore, the graph of the function will be like this. So here, open circle will be there. Is this the graph or not?
Yes, sir.
So this is the graph of y is equals to y1 is equals to ln 3 by ln x. This is the graph. Next one is this graph. It's a straight line, simple straight line. y2 is equal to 2x minus 3. y2 is equal to 2x minus 3. Slope is 2. That is, angle is acute angle only. That's why where it intersect the x-axis, on x-axis y0, x equal to 3 by 2. It intersect the x-axis 3 by 2. This is 1. 3 by 2 will be 1 point. That is somewhere over here. Therefore, the graph of y is equal to y2 will be like this. Yes, sir. This is the graph of y2. So y2 is equals to y2 is equals to which graph is this? 2x minus 3. Yeah. 2x minus 3. Therefore, from the graph we can say the number of solutions are what? 2. Yes, sir. So this is the answer. From graph, number of solutions are